I would like to introduce the Executive Director of Spire, Loredana Ghinea. Thank you. Big round of applause. Yes, that's good. Show your spirit.
Thank you. Thank you very much for welcoming here in Barcelona. And I would actually need you to use your imagination in the next couple of minutes, because I'm not going to talk about 3D printing, but I'm going to talk about opportunities, about the industries that are actually producing the materials that are used for 3D printing, and I'm also going to talk about the challenges that this industry may have in the very near future. I'm going to talk about a public-private partnership that is called Spire, and Spire stands for Sustainable Process Industry through Resource and Energy Efficiency. Process industry, some people may ask, what is that? It's actually something that sits between what the majority of people understand from basic resources produced and getting into our lives as final products. The automotive, the aerospace, the transport that we all use. But here in the middle, of course, is the black box. It's the miracle that occurs and that may need some explanations, because this is where everything happens, where the physical chemical transformation of these basic resources happens to give us the best of that. And it's a magic box, actually, because it contains the industries that produce all this stuff. We are talking about minerals, metals, steel, chemicals, engineering, ceramics, cement, and water. And these industries have challenges, because we have less and less resources, but we have more and more needs. And especially, the challenges are that these industries are in Europe, and do we have all these resources in Europe? We need to address this through innovation in resource and energy efficiency. How do we do that? How do we nurture a new industrial renaissance? We have in front of us traditional industries, but we need them, and we need to do something about their rejuvenation. We do this by getting away from a concept that is only about me, and we need to lead them towards a concept that gets to a we. How do we work together? How do we produce something that is best for us and for our future? So this is where the public-private partnership come in. It's officially launched in December 2013 through the European Commission instrument, which is called Horizon 2020, an instrument that is actually about research and innovation and investing, funding projects that are dealing with the challenges that I have mentioned earlier. It's spread over seven years through calls that are coming out, are funded by the European Commission, and are delivering on the challenges ahead. So what it's meant to do is to lead us from the today's scenario where you have the oil-based resources, where you have a plant that emits a lot of emissions and uses a lot of energy, where you have the materials and all of this goes to waste. And we want to lead them to a tomorrow scenario where you actually invent or reinvent the feedstock. You're using waste. You're looking into bioresources, renewables. You're actually using CO2, transforming it from a pollutant into a resource. We are looking into a scenario where we reduce emission, where we invent or reinvent energy and resource management concepts, including industrial symbiosis, closing the loops, having industries working with each other. We are introducing digital devices for better monitoring and control. We are inventing or reinventing materials for optimized processes. And an element where 3D printing has something to do, where we reinvent the processes and the materials that have a significantly increased impact on resource and energy efficiency down the value chain towards transport, towards housing, towards construction. And last but not least, we are reducing the waste and reinvent the technologies for the valorization of these waste streams within the sectors, but also and especially across the sectors. Expected impacts, we are looking actually into a reduced energy intensity. We are looking into a reduction of renewable primary raw material, and also in an efficiency improvement of CO2 equivalent footprints, and of course, growth and jobs. The percentages that you see there are quite high, and you might say, okay, this is very ambitious. What we actually want to do is transform the impossible into 2 words: I'm possible. We started in 2014. We already have a couple of calls and projects that started in 2014 and 2015. And I wanted to give you a very slight overview of what these projects are dealing with. We are looking into adaptable processes using renewables, and one of them is the utilization of CO2, for example. We're looking into advanced fuels that are coming from CO2. And of course, these has enormous benefits. It has environmental benefits because it could possibly help us reach the European Commission target of 10% of renewable energy. It may reduce the dependency of Europe on other energy sources. And of course, the economic benefits are tremendous if we can manage to do that. Also, in terms of the utilization of renewables, we have to think of how do we use our fields and forests. And there is, for example, one project that is looking into converting agroforestry residues into stable feedstock. And of course, they are looking to do that into decentralized business models. There's some other projects related to process optimizations. One of them is looking into membrane reactors. So it allows the integration of different process steps in a single multifunctional unit with significantly higher yields. We are entering another field with modeling and integrated process control. We are not looking into a huge factory that we traditionally see, but into flexible, continuous plants where you have miniaturized equipment, where you can have different modules, where you still can benefit of product uniformity and be responsive to the market demand. Again, the impact could be tremendous. Millions of euros per year in savings, making processes resilient to variances in feedstock and external disturbances, and even less consumption of non-renewable raw materials and reduction of CO2 emissions. Another project that is in the same field, but this time very much cross-sectorial. I mentioned that there are several sectors working together. We have the examples, for example, of liquid steel making, polymerization, and silicon refining, and how they are trying to make their processes more optimized in terms of energy and raw materials. Again, significant figures in terms of reductions of emissions, but also in terms of automatization, reduced risk exposure of workers, process stability, and higher operation time. Another field that is quite interesting is the recovery from waste. You know that all our high-tech material contain rare earths or very useful minerals and metals. We need to be able to find the recycling technologies that are improving the process efficiencies in sectors down the value chain. And this is what this project is trying to do. Basically, is looking and will get there in terms of saving 40% of consumption of energy, removing impurities, or 100% of recovered materials in the final alloy, 85% efficiency in recovering the rare earths. So it's quite impressive. We also have a field that is called integrated resource management and life cycle management. This one, for example, this project TASIO is recovering the waste heat from one industry for the use of another. And that's tremendous, because it's not only talking about the use of the waste heat, but also how the interactions between the industrial and the urban environment can be made more efficiently. Chemicals, cement, steel work together in elaborating ways of collaborating and making use of each other's resources. This again, tremendous impact expected in terms of decrease in total investment costs. These are industries that are heavy in risks taking, but also in terms of the investments that are needed for the implementation of the technologies. We are also, therefore, looking into recovering the installation costs and reducing the time to do that in order to be efficient. And finally, a last field. It's actually about the soul of Spire. How do we take advantage of several industries working together? And basically, this project comes with a new paradigm for industrial clusters, the sort of human mimetic symbiosis that is happening there. And as you could see, and I will not go through all the figures, but it's quite impressive what they will try to achieve. Unused waste will be put to valor. Material use and its reuse. Life cycle carbon emissions of the cluster, so several industries working together, will go down. Recycling, symbiotic recycling is one of the key features. And of course, the overall resource consumption and the costs that come with it. Now, you've seen all of this, and you may wonder, okay, but what does it have to do with everything that we are talking about today? We are talking here about a new field, a new industry, innovative stuff. We are hearing only traditional industries talk. Yes, indeed, but sometimes you need to have an old-fashioned whack on the side of the head to get into a creative breakthrough. You need the old industries to rejuvenate themselves in order to give the substance of the new industries and find ways to get to the needs that we have and cover them in a different way. Factory in the sky, in the cloud? Yes. The traditional industries have integrated and will continue to integrate new technologies. We are talking about modeling, simulation, and forecast in modeling of materials, in reactions, in studying thermodynamics and dynamic phenomena. We are talking about getting cognitive plans into these traditional sectors. Intelligence of learning system, integrated automation solutions, in order to make sure that the process routes are taken into account and all their aspects are considered. Advanced maintenance, allowing remote control of equipment, prediction and prevention of failures is really important to get to the results that you want. Cloud technologies, yes, we've heard that we need to communicate. Well, industries, plants need to communicate if we are to look at our economy as a symbiotic system and make sure that from the basic resources all along the chain to the end result, to the end consumer results, we are all covered, all our challenges are dealt with. 3D printed factory, why not? But for the moment, I think that we can start to talk realistically about elements, parts of it, impossible shapes, lightweight, biomimetic structures, completely new features that these factories may use. And also their integration. We can look into moving parts and their consolidation in order to improve the processes. So what I'm trying to say here is that use your imagination to match past, current, and future. And innovation is weakest or strongest at its weakest or its strongest point. So we need to make sure that all the little chains are as strong as possible to lead us to the future that we all want. Thank you very much.